Welcome back to another video, and today we'll be discussing about LCS. So LCS stands for longest common subsequence, and this is a part of dynamic programming, and the main concept here is to find the longest sequence, let's say between two strings. So in these two strings, what is like the longest sequence of characters that are common with one another? So as of all dynamic programming problems, we'll be working this out using a table. So I've already written down the values. So initially row 2 and column 1 will have 0 values. Now we'll be filling up all the other boxes here. So let's get on to it. So first thing that we'll be looking into is this portion. Is A and A common? So of course they are, so we'll be putting a value here. What would be the value? It could be diagonally plus 1. So diagonal value plus 1. So this is 0, right? So 0 plus 1, that would be 1. So we'll be putting 1 here. Okay, so moving on. So in this case, we'll be looking into what is common. So A and A is common, right? And A and B is not common, of course. So we'll be putting 1 again. And similarly for C and D, we'll be putting 1 again. Now we have to check in this place. So A and A is common, right? So the task of A is done. There is no more A, let's say, and so we cannot check with nothing and A. That's not common, right? So we'll be putting 1 here again, and for F that would be 1 because nothing is in common. Now for this case, we have only A and A common, so we're putting 1. A and C is not common, like C is not common with A or B, so we'll be putting 1 again. However, in this case, in this portion, so A and A is common, but C is common with not B, only C, right? So we'll be putting the diagonal value, this one, plus 1. So that would be 2 here. So we'll be putting 2. So again, first D, so only match here is A and C and C. So C doesn't match with D, so nothing new. So we're putting the max value from either the left or the top. So the left is 2, the top is 1. So of course we'll be putting 2 here. And similarly for A, we'll be putting 1. As I said before, we counted only one time, so 2 again. So A, B, C and A, one thing common, 1. And for A, C, B and B, we have A and A and B and B. So we have two things, right? So diagonal value, which is this one, plus 1. So that would be 2. Again, for this case, so A is common, C is common with this one, B is common with this one, right? So it would be diagonal value plus 1, so 2. And for D, so neither B, C or A is common with D, right? So we'll be putting the max value from either the left or the top, so we'll be putting 2. Similarly for A, 2 and F, that would be 2 again. Now for this case, we only have one thing in common, so 1. And for AB and AC, BC, so we have only one thing in common. So two things in common, so A and B and B, so that would be diagonal value plus 1, 2. For this case, we have A and A, B and B, C and C, right? So we have another value that is common with this one. So C and C, we only had A and B at the first, like A, C, B, C and A and B. So that gave us 2, right? Now we have another value, so C. So we are comparing AC, BC and ABC. So we have 3 things in common. One thing is new, right? So diagonal value plus 1. So 2 plus 1, that would be 3. And for D, nothing is common, so we put the highest value from either the left or the top. So 3 again. For A, 3 again. For F, 3 again. Now we're at the final stretch, right? So let's look into every portion. So A, C, B, C, F and A, only one thing common, so we put 1. A, C, B, C and F, A and B. So two things in common, right? So diagonal value plus 1. So 1 plus 1, that would be 2. AC, BC, and F and ABC. So 1, we have 2, we have 3. So diagonal value plus 1, 3. And for AC, BC, F and ABCD, so nothing is new. We already did the whole process again. So D, nothing is common with D, right? So we put 3 again. For A, nothing is new. We already did it. So 3 again. However, on the last box, so A is common with A, so 1. C is common with this, so 2. B is common with this, so 3. C is common with, but we are not counting this. F is common with this, so something new, right? 1. So 1, 2, 3. So we look into the diagonal value, which is 3 plus 1, that would be 4. So our answer is the longest common subsequence between them is 4. But now we have to find the characters which will be showing what is like the characters that match with string 1 and string 2, right? So we start from this value, right, 4, which is like the last value that we put into the table. And look if 4 is unique or not. So 4 is uniquely generated, right? So we pick 4. So we pick this column, which means we are picking if. Now we go diagonally up and we go to 3. So is 3 uniquely generated? No, it came from the left side. Is this 3 uniquely generated? No, from the left side. Is this 3 uniquely generated? Yes, it is. So we'll be picking C as our common character. Now we go diagonally up. Is this 2 uniquely generated? Of course. So we'll be picking B, this one, and we go diagonally up. Is this 1 uniquely generated? No, it came from the top, so we go to the top. Is this 1 uniquely generated? Yes, it is. It didn't came from the top or the left. It gained a value diagonally from 0 plus 1, that we 1. So 1 here. So this is a uniquely generated value, so we pick A again. A, not again. So this is the characters that match with the strings, like from string 1 and string 2. These are the characters that match, and this is the longest common subsequence. So hope you guys did understand this. I know the concept is a bit tricky, and it's like harder to understand it by seeing some videos or reading books and articles. However, I would really want you guys to look into other videos if this one got really complicated, and do practice it with other let's say strings, and try to do this on your own. And I'm pretty sure this is gonna come in your exams, but do practice this a lot. This is something that people mess up a lot. Thank you for watching, and if you have any comments or suggestions or any ways I can improve my videos, I would love to hear it. And thank you for watching.